Hey everybody, Mr. Beckstrom back. Today we're going to be talking about Chapter 3.1, Angle Measurement. Let's get started. So this section and this chapter is going to start looking at some angles. We'll be looking at some angles of triangles. We'll also be looking at some angles when a transversal line cuts through a pair of parallel lines. And that's what we're going to do to start here today. So let's kind of define a couple of important things first. So what is an angle? You've probably heard the term quite often. It's the measure of the size of an opening between two intersecting lines. So in this case, we have this upper line and this lower line. They intersect at the vertex. So the two lines are called sides. And the angle is that opening between those two lines. And normally we say that the angle is the smallest opening between those two sides, because we could also talk about the angle on the outside here as well. So we're going to have some important definitions for this section here. Let's talk a little bit about them. An acute angle is an angle less than 90 degrees. So once again, a 90-degree angle is also a right angle. That's where two lines intersect perpendicular to each other, and they form angles that are 90 degrees. So an acute would be less than that. An obtuse angle is an angle greater than 90 degrees. A right angle is exactly 90 degrees, how we just talked about that. Perpendicular is when two straight lines meet at a right angle, at a 90-degree angle. We say that those two lines are perpendicular to each other. A straight angle is an angle that's 180 degrees. That's where your vertex lies somewhere on a straight line, and the entire angle would just be 180 degrees. A vertical angle, that's the opposite angles of two intersecting lines. We'll be taking a look at some of those in our second example. An adjacent angle, those are two angles that share a common side. They're next to each other. Parallel is two lines that never meet. The distance between them remains constant along both lines. And a transversal is a line that intersects two parallel lines. And that will form some interesting angles that we'll be taking a look at once again in example 2. Alright, so let's first kind of formally define a triangle, and then we'll look at some properties of the triangle and work a problem here. So I'm sure you've seen triangles before, but we need an exact mathematical definition for them. And in this case, there's a lot of definitions, but we're going to say that it's when line segments form together to create three vertices and three sides of a triangle. We have some properties of those triangles. We say that the interior angles, the angles in the inside of the triangle, will always add up to be 180 degrees. So let's take a look at this triangle here. We have three interior angles, and we know two of them. We know one of them is 95 degrees and the other one is 55 degrees. So if we're asked to find the measure of angle A, which would be our remaining interior angle of this triangle, how would we go about finding that? Well, we know that all three angles added together have to be 180 degrees. We're going to use that fact, so we know that the remaining angle is going to be the difference between that 180 degrees and the two angles that we already know. So what we can do is we can set up kind of an algebraic problem with the three sides, knowing that they have to be 180 degrees. Put in our known information, which we know that one of them is 95 and one of them is 55. We can subtract both of those quantities from our right-hand side to get A, our unknown interior angle by itself. And you can see that if we take 180 degrees and subtract the other two angles, we get 30 degrees. So that would be the measure of angle A. Alright, so now let's take a look at when two parallel lines, that would be this line and this line here, when it's cut by a third line. This third line that cuts through these two parallel lines is going to be called the transversal. And any line that isn't parallel to either of those lines is going to end up being a transversal. So what do we mean by alternate interior angles? corresponding angles, and we'll also look at vertical angles. Well, vertical angles are angles that are opposite each other. For example, 1 and 4 are vertical angles. 5 and 8 are vertical angles. 6 and 7 are vertical angles. And 3 and 2 are vertical angles. Nice thing about vertical angles is that they're equal to each other. So 1 is equal to 4, 5 is equal to 8, 6 is equal to 7, and 2 is equal to 3. We have alternate interior angles. Those are angles that are kind of alternating between one side and the other. So for example, one side and the other, but they're both interior angles. So interior would be inside the two parallel lines here. So 3 and 6 would be alternate interior angles because they're interior, but they alternate from both sides of the transversal. 4 and 5 are alternate interior angles. Once again, they're both on the inside of the parallel lines, and they alternate on either side of the transversal. Corresponding angles, those are angles that correspond with each other on both sides of the transversal. So for example, 3 and 7 would be corresponding angles. 4 and 8 would be corresponding angles. 2 and 6 would be corresponding angles, and 1 and 5 would be corresponding angles. The nice thing about all of these, the vertical angles, the alternate interior angles, and the corresponding angles, is that they're all equal to each other. So alternate angles equal to one another, and the same is true for the corresponding and the vertical. So let's look at this second example here. Suppose that we have this pair of parallel lines cut by this transversal here. If we know that angle 1 is 110 degrees, what are the remaining 7 angles? Well, what can we do to find those? Well, there's actually a lot of ways to go about it. If I'm going to use corresponding angles, I already know that 5 would be 110 degrees, right? And I also know that 4 would be 110 degrees because that's a vertical angle. So the corresponding angle of 5 and the vertical angle of 4 both have to be 110 degrees. And then if I know 5 is 110 degrees, I know that vertical angles to it is also going to be equal. So 8 would have to be 110 degrees. So I've already got 4 of my angles, and they're all 110 degrees. Well, what about the other angles? Well, once again, there's a lot of different ways we could find that out. And remember, we talked a little bit earlier about a straight angle. A straight angle is an angle along a straight line. So this angle here going from 1 all the way to 2, the total is going to be 180 degrees because it's half a circle. So if we know that this total angle is 180 degrees, and we know that angle 1 by itself is 110 degrees, well then we can find that angle 2 has to be the remaining of the 180 degrees. So 180 minus 110, that's 70 degrees. So if we know angle number 2 is 70 degrees, then we know that angle 3 is 70 degrees because of vertical angles. Because of alternate interior angles, we know that angle 6 is also 70 degrees because it's an alternate interior angle to angle 3. And then because of vertical angles, we know that 7 is also 70 degrees because it's vertical to angle 6. And you can see the solution. We went through here. We started with the one that we know, the known angle. We found those other 3, and then we used the straight angles to find the last one. So that's just one way you can go about and calculating those answers. All right, thank you and have a great day.